Good day, everyone. My name is Andriy Volushchuk, and I am delighted to present our paper titled Computer System for Energy Distribution in Conditions of Electricity Shortage Using Artificial Intelligence. This work is a collaboration between Andriy Volushchuk, Diana Velichko, Halina Usukhivska, and Andriy Palomar. Nowadays, electricity shortage or blackouts can occur due to various situations. These circumstances include the weather conditions, accidents, or any other unforeseen events, a prime example of which is Russia's missile attacks on Ukrainian civilian infrastructure. It resulted in electricity shortage for Ukrainian civil population and infrastructure. One of the massive attacks was in November 2022, caused a massive blackout in Ukrainian power grid. To improve the situation through redistribution of resources and allow access to electricity for all units, electricity availability schedules were introduced. Such schedules were being developed over a long period of time. They did not always ensure an even distribution of electricity among consumers, and they did not effectively take into account challenges in the volumes. To respond to such challenges more quickly, it is advisable to use all the capabilities of modern technologies, particularly artificial intelligence, and implement the intelligent energy accounting system. The study is aimed at identifying effective strategies for utilizing artifact intelligence for automated development of electricity management algorithms in situation of energy crisis and resource constraints. The state of the art is using artificial intelligence is suitable energy, including renewable energy, and the energy efficiency is described by the number of the scientific works. We have studied many articles by the other authors, and they've been involved in the predicting short or even medium-term electricity consumption, and even in using genetic algorithms to intelligently control electricity and optimize power system. But they not focused on the power outage schedules, but we focus on this more detailed. So this paper is devoted to the actual problem of introducing and using AI in the energy sector of Ukraine to distribute electricity in conditions of shortage. To fulfill the data collection objective of the research, the proposal suggests utilizing the framework of the computerized energy enterprise system. Adopting the framework of the computerized energy enterprise system rooted in the Internet of the Things concept is advocated. Generally, intelligent systems comprise smart meters, mobile modems, enterprise routers, switches, etc. The system receives real-time data streams from the variety of the resources included current and the voltage transformators, protection relay, and various sensors distributed throughout the electrical network. Operators gain a comprehensive understanding of system dynamics, including load fluctuations, voltage stability, and the equipment conditions, and enabling them to make informed decisions regarding maintenance, optimization, and resource allocations. For secure and dependable communications, smart networks employ various additional technologies. It is also important to protect the data which we operate later, so we use various security protocols and follow the general recommendation from Cisco security best practices. By integrating these technologies, smart network can surmount communication obstacles and establish a more efficient and secure energy management system. For the optimal and the fast distribution of the energy resource between consumers, it is advisable to use the method of the artificial intelligence to search for the most efficient combination of electricity consumption zones at a given time within the limit resources. It is proposed to use the genetic algorithm. In this context, genetic algorithm can be used to build the schedule of electricity availability in these zones, which helps distribute energy resource quickly, more efficiently, and evenly. The following formula is proposed as a fitness function. This way, the genetic algorithm has the following presentation. Each gen of the chromosome represents a zone. Each chromosome is a list of the zones to be powered simultaneously. Each gen has its own value and the weight. In our case, the value is the number of the entities that gain access to the electricity in the zone. The weight is the amount of electricity power needed to electrify the zone, as the amount of the electric power is limited in case of energy shortage, and this limit can change at any time it is the most important resource to consider as the constraint on the fitness function. The GH algorithm is run for a few epochs, while the important values are changed in a way presented in the figure 2 to provide all regions with electricity without giving preference to just some of them. The best individuals from all epochs are saved at the schedule of electricity availability. These schedules are then evaluated for fitness based on the total importance of the included regions without exceeding the available electric power. The best selections are chosen using tournament selection technique to create a new generation through crossover, that's like combination part of two chromosomes, and mutations, that's randomly alerting parts of the chromosomes. Over the multiple generations, the algorithm evolves towards an optimal set of regions that maximizes total importance within the available electric power constraint. To generate a simulation of the situation in which the algorithm should be used, we will use a data set of hourly energy usage that can be found on the internet in the open source database kaggle.com. That dataset, which contains hourly energy consumption level provided by the different US energy region, was also used for the safety reasons for the Ukraine. We have the whole data in the CSV file, then we can import any of the metric or the monitoring system and build the graphs, any tables whenever we want. The genetic algorithm should only be a part of the system software. It should be used in the cycle outlined. Firstly, it is important to understand that the schedule is divided into certain time periods. We use like a 2 hour, it could be more or even it could be less. J should be run for each time period separately. The regions are already defined as well as the number of the entities affected, the average amount of electricity power needed for the region, and the power limit. The main advantage of the algorithm is the fact that it provides a result significantly faster than any human operator and promotes equal distribution of energy sources based on importance. In addition, the schedule can be changed dynamically when more energy is available. Knowing how much electricity is needed to meet the needs of all regions has important benefits. Having the data will allow you to plan some maintenance and rebuild some communications nodes without inconveniencing consumers. This can solve a lot of the problems, increase performance, and provide a lot of the benefits. The generate schedule of electricity availability using the proposed algorithm for 11 regions with conditional limit of 70,000 megawatt is shown in the figure 4. The proposed computer system was designed for energy distribution in conditions of electricity shortage using artificial intelligence. The integration of AI into energy accounting system presents concrete advantages in improving data accuracy, minimizing manual errors, and boosting overall system performance. AI-powered solutions facilitate efficient energy distribution, cost reduction, and swift response to power shortages. The proposed GA method provides a streamlined approach to distribution energy resources, ensuring equitable distribution and dependable energy supply. Understanding regional electricity needs leads to better supply planning and heightened system reliability and fosters economics and environmental efficiency in the energy industry. Ultimately, AI-driven solutions play a pivotal role in tackling challenges and optimizing energy management during crisis and resource limitations. This computer system may be used not only in Ukraine, but in any country, region where a power outage or shortage may appear due to several weather conditions or any other unpredictable events. Thank you for your attention.